All right, part 3, video C here. Our equations are getting a little more interesting now. So now there's actually something in there with the theta. Anytime there's something inside the trig function with the theta, it is critically important to use the 2 pi k, because that whatever's in there with the theta impacts the 2 pi k potentially. Okay. So this is asking us tangent of theta minus pi over 2 equals 1. So our first question is, now our ugly is all that stuff inside. So it's really tangent of ugly is 1. So where is tangent 1? So tangent is 1 when sine and cosine are equal. They're equal at 45 degrees, pi over 4. So that's first quadrant and third quadrant. So pi over 4, 2, 3, 4, 5. Pi over 4. And that is because everything's positive there. Tangent's positive in quadrant 3 because sine and cosine are both negative. So tangent of crazy mess equals 1 when crazy mess is pi over 4 or 5 pi over 4. So we have u equals pi over 4. Or u could equal 5 pi over 4 plus 2 pi k plus 2 pi k. Alrighty. Now let me kind of shrink that a bit. And then we're gonna move all this over here. There. All right, so now we're gonna put what we had for ugly back in there. So that is theta minus pi over 2. Now there are some other ways that we could have dealt with theta minus pi over 2. Like technically that's tangent, a difference of angles. Like we could use that formula, but it's gonna give us something really, really ugly. We can also just handle it with the 2 pi k. So I have my pi over 4 plus 2 pi k and theta minus pi over 2 equals 5 pi over 4 plus 2 pi k. Now it can be really tempting to not write the 2 pi k initially, but if you get in that habit, then when it matters, you won't have it written and then it'll be missing. So here, like the pi over 2 is not actually going to affect the 2 pi k. It's just going to affect the front number. But anything else, and it would have an impact. So I think it's better just to stick with the 2 pi k all the time, and then you just reduce it down by using k equals 0, k equals 1, -1, whatever you need. All right. So to get theta by itself, I have to get rid of subtracting the pi over 2, so I'm going to add the pi over 2 to both sides of the equation. Of both equations. All right, so pi over 4 plus pi over 2. Pi over 2 is 2 pi over 4. So 1 pi over 4 plus 2 pi over 4 is 3 pi over 4. Now I'm combining these because they're like terms. The 2 pi k has a k. The pi over 2 we added does not have a k, so they don't interact. Now if I was multiplying or dividing, then that would have an impact on the 2 pi k. But if it's just a minus or an add, it just shifts that starting number. So this stays 2 pi k. And then over here, theta equals 2 pi over 4, 5, so 7 pi over 4, plus 2 pi k. Now, tangent technically repeats itself every pi instead of every 2 pi, because pi over 4 plus pi is 5 pi over 4. 5 pi over 4 plus pi would give us 9 pi over 4, which is coterminal with pi over 4. Like, you can write a little less with tangent, but I prefer to stick with this format because it's consistent. You find the two angles on the unit circle, you write them down with plus 2 pi k. Like, it's less trying to remember the, wait, what's the weird stuff with tangent? Wait, what do I do here now? All right. So 3 pi over 4 is still on the unit circle, as is 7 pi over 4. And they only wanted from 0 to 2 pi, so our answer will just be those guys. If I go 2 pi plus 3 pi over 4, I'll be outside the range. If I subtract off 2 wholes, I'll be negative outside the answer possibilities they asked for. All right, so a little bit weird, but not too bad. I know, a little tedious with all the 2 pi k's I wrote everywhere. All right. Same song, second verse. In fact, this one actually starts out a little nicer. All right, so tangent of x is square root of 3. On the unit circle, tangent is square root of 3 when the sine is square root of 3 over 2. So this is where sine is 1 of the square root of 3 over 2. So in quadrant 1, that's the long side in the y direction. So that is 60 degrees, which is pi over 3. And that quadrant 1 is positive. We are looking at positive square root of 3 because the cosine would be 1/2, so the over 2's cancel, so it's just square root of 3 over 1. So we have pi over 3, 2 pi over 3, 3 pi over 3 is pi, so then this one is 4 pi over 3, which again is pi over 3 plus pi, and 5 pi over 3. All right, so over here, our x could be pi over 3, or it could be 4 pi over 3. And both of these get a 2 pi k. And they didn't tell us a 0 to 2 pi, so that's it. That's our answer. Now, technically, since those are pi apart, and then we're adding the 2 pi to each other one, we're actually just getting pi over 3 plus pi k. But seeing that that's the case and reasoning through how to write it as one formula, it's not worth the effort. It's just one of those, like, yes, technically that's true. And if you're writing the answer down, like on a test, you know, just on the off chance somebody not in my class watches these videos, that is the full and complete answer. But for my purposes, the two answers is preferred, actually. Because that is the method that applies consistently. All right, we got one more with tangent here. This one does reduce things down, but they did something annoying. There is a 2 being multiplied to this mess, and then there's a tangent on the other side. Why? Because they could. There is no rhyme or reason to the why we do these things. All right, so I have 2 thing plus 3 with parentheses, and 5 plus thing. Thing shall be u for ugly, because I don't like tangent, it's ugly. I promise you, you're going to get to calculus and they're going to do u substitutions, and then you're going to hear me saying u stands for ugly. The other calculus professors don't know that. But you pick whatever the ugliest thing is, that is almost always what your u is. So if we distribute, we would have 2u plus 6 equals 5 plus u. All right, so we got some like terms to move around, so we're going to subtract the u. 2u's minus 1u is 1u, not 2. And then since I have the u by itself on the left, I'm going to take that 6 and subtract it over. And so I have u is negative 1. All right, well, u was tangent of x, so now I have tangent of x is negative 1. Now we just talked about where tangent was positive 1. That was our pi over 4 and 5 pi over 4. So this is the reverse, where sine and cosine are not the same sign. This is quadrants 2 and 4. So x can be 3 pi over 4 plus 2 pi k. And x could be 7 pi over 4 plus 2 pi k. But since they gave us the restriction here, those two guys will answer it. If you're not sure, you can plug in 1 for k, add it together, see if the number without the pi is between 0 and 2. You're going to see it's not. But until you get comfy with that, like, you can't always check it that way. They are all correct answers. There's just a short list that are between 0 and 2 pi. Yep, got quadratics next, so we'll cut this one here.